In this data project, we will focus on exploratory data analysis of stock prices. Keep in mind, this project is just meant to practice our visualization and pandas skills. It is not meant to be a robust financial analysis or to be taken as financial advice. Today, we will focus on some US bank stocks and see how they progress throughout the financial crisis, all the way up to early 2016. Then do a quick comparison with the last 10 years data. Please watch along if you find it interesting, and feel free to work alongside if you want to practice this course too. So let's get started. So here, first up, we will start by importing some of our important libraries. So we imported numpys, pandas, matplotlib.pyplot, and cbound, and also ran one line code %matplotlib.inline so that the visualizations show up in the Jupyter notebook. Now, along with this, for today's exercise, we will also import datetime as dt, because we will be working with dates as part of time series analysis, and we will import yfinance to pull some stock data. So we will also be building some interactive visualizations. So for that, we will import plotly and cufflinks. Cufflinks connect pandas data frames with plotly library and helps to run the visualizations directly of the data frames. So next, for today's project, we need to get data using Yahoo Finance. We will get stock information for the following banks. So what we have to do here is, we have to pull the stock data for these banks from Jan 1st 2006 to Jan 1st 2016, then set each of the banks to be a separate data frame with the variable name for that bank being its ticker symbol. So let's start by importing start and end datetime objects first. We'll create this variable for start. It will be dt.datetime. We can use datetime, but for this project we don't necessarily need time information, we just need the dates. So I will select the date option, but you can also select datetime and put in just the date info. You can directly put in the year, month and day if you're putting it in this order. Otherwise you can declare the parameters year, month and day, both will work. Let's see, start is a datetime date object with year 2006, month 1, day 1. End is also a datetime date object with year 2016, month 1 and day 1. Next we need to pull the stock information from the yfinance. How we will do is, we will make these data frames and pull data using Yahoo Finance library which we imported. If you are using Yahoo Finance for the first time to pull information, you can install the package by using pip install yfinance in your command prompt. Here we just need to input the stock symbol, stock ticker, then start date and end date, which are our variables start and end here. Then we will do the same for other stocks. The stock ticker for Citigroup is C. Goldman Sachs is GS. You can Google and check the stock tickers for not only these stocks but all of the other stocks as well. JP Morgan is JPM. Morgan Stanley is MS. And WFC for Wells Fargo. Run this. It will take some while to pull all of this data. So we have got all of the stock data downloaded as data frames in our Jupyter notebook. Let's check this one by one. So in total this has 2517 rows for 10 years and 6 columns. Those were open, high, low, close, adjusted close and volume for each trading day. Let's quickly check other stocks as well. So we are all good here. Next, we will create a list of the ticker symbols. We will call these tickers. You can directly create the list, but what I am going to do is to create this as a string and then use dot split method, and that will convert it into a list. Use dot split method and check the tickers list, and we have our list. Next, we have to use pt.concat to concatenate the bank data frames together to a single data frame called bank stocks, bank underscore stocks. So what we have to do here is use pt.concat, pass in a list of the data frames we want to concatenate together. Remember, these are data frames, so we won't pass it as string, not like this. These are all variables. Now just check, if I just do this, what will happen. Let's run this and check bank underscore stocks. So what has happened here is there's a total of over 15,000 rows and 6 columns. So the data frames have all glued together one below the other in this order. So the date should be repeated. It will start from 2006 13, will go all the way up to 2015 12 31, because 1st January 2016 was a holiday. It wasn't a trading day. And then it will repeat again for the Citibank group. It will then repeat for Goldman Sachs and for rest of the stocks. We don't want the dates to be repeated over and over again in the index. What we want the other bank data is to be on the right of this Bank of America stock. So for that, we could pass in axis is equal to 1. So this will glue it on the columns. See, now we have all of our stocks on row wise. If you check this data frame, now it is back to just 2500 rows and 36 columns. 6 into 6 is 36. But here we don't know which one belongs to which stock. So for that, we can pass in keys. And for that, we will use our tickers list, which we created here. Now check now. The first one is Bank of America stock. We have 6 columns for that. Then it is Citibank. We have 6 columns. Similarly, at the end, we have Morgan Stanley. and then we have Wells Fargo. Next, we will set the column name labels, bank tickers, and stock info. So if you check the column names here, column is a multi-index column. On the level 1, we have the ticker names, which is BSE, CEMS, all of those. And level 2, we have this data about open, high, low, close, adjusted close, and volume. And this is repeated. So it is a multi-index column and it doesn't have a name. If you check the name of the levels, it is a frozen list with none. You can replace this by just passing a list. For level 1, we will name it bank tickers, and for level 2, we will call it stock info. And now if I check the head of the data frame, see, when we first check it, it didn't had any information here. But now the first level of the multi-index column is called bank tickers. The second level is called stock info. The index for these levels are 0 and 1. Now that we have got our data frame, we will start with our analysis. So let's explore the data a bit. What is the maximum closing price for each bank stock throughout the time period? So what we need to do here is find the maximum closing price for each of these stocks. So for BAC, we want the maximum value from this close row, and we don't need the other rows. So what we could do here is we could use a cross section for multi-index data frame. Let's call our bank stocks, use cross section. For this we will use a key which is close because that is the data we want to see, and then we will have to put in two additional arguments. Those would be for axis and level. I will show you one by one. First is close. Let's run this and check what happened. It will show an error. So the error is key error close. So what pandas did is it went looking for this keyword in the index and it couldn't find it anywhere because it is in the columns. So we need to inform it that it is in the columns. So go check axis 1. Axis 1 is for column, axis 0 is for row index. It again gave a error, same key error close, because now it checked at the first level of this multi-index column and it couldn't find close anywhere because it is in second level, which is level index 0, level index 1. Now it got it. So what this returns is just a data frame with just those close columns. We have our dates on the row index and our bank tickers on the columns and just the closing data for each of the stocks for each trading day. So from this, what we have to do is define max close price for each bank stock throughout the time period. This is very simple. You can just run the max method here and it will return the max value of each column. Ta-da! So we have our maximum closing price for each of the stocks for that time period. If you wanted maximum value for the rows, you can use axis is equal to 1 and it will find a maximum across the column for each row. But this is across different stocks, so it doesn't make much sense. We will go back to our axis is equal to 0, which is there by default. Now next we have to create an empty data frame and we will call this data frame returns. Just pass this and see what happens. It will just return a single dash here representing empty data frame. You could use print here to print this returns data frame. It will return empty data frame. It doesn't have any column or index info. So use pandas percent pct underscore change method on the close column to create a column representing this return value. Create a for loop that goes and for each bank stock ticker creates this returns column and sets it as a column in the returns data frame. So what we have to do here is create a loop that goes through each ticker and then return a column, returns column. So for this empty data frame we will create a column where those return data would be stored. So returns data would basically be what was the return for each day. Let's start by creating a for loop for I in tickers. Um, See what tickers was. Tickers was a list of all the data frames stored as string. So this will go through each of the elements of this list one by one. And what I want is to add this columns in this returns data frame which is empty. I need to give a column name. The way I will do it is use this I and then concatenate that with the space return. So I want the name to be in this format. So the column name for the first element would be BAC space returns. For second, it would be C space returns. Now what I have to do is find a return from the close column. So we have our original data frame, bank stocks. We'll take the cross section just like we did in the last uh, step. Then once we get our data frame with just the close information, we can grab the I column. I would be for each of these strings. So it will grab just that column for each ticker. And I can use this method pct underscore change. Now what this will do is, if you see here, if I grab just BAC and then grab close, this will just return a series of the closing date of the BAC ticker. And if I use this pct change here, so this is basically I'm checking the signature of this method. We need to put in the period which is by default 1. So for every column it will calculate the return it had. For every row it will calculate the return compared to its prior row. This is fractional change between the current and prior element. Computes the fractional change from the immediately previous row. By default, this is useful in comparing the fraction of change in a time series of elements. So remember, this will be a fraction, not a percentage. If you want the change to be in percentage, we would need to multiply it with 100. Let's just calculate this, run this and see what happens. Now here we will check our returns data frame now. So we have got columns for each of the stock tickers for each trading day. For the first day, obviously the return is not applicable because there wasn't a prior element for it to calculate it. But from the second row, we can see the negative and positive returns. Negatives were the days where it went down, and positives were the day where it went up. If you multiply this with 100, it will give the returns in percentage. These are now in percent change. We'll go back to our original returns. Now next, we have to create a pair plot using Seaborn of the returns data frame. So what we could do is create a pair plot. We need to put in our data. Let's do that first. See what happens. It will take a while because there's a lot of data in this data frame. So here the diagonal elements are univariate data, that is just for that particular column, and then off diagonal elements are bivariate data. So what pair plot does is it creates a, a plot, a scatter plot for each pair of the numerical data in the data frame. So for example, it will create a BAC versus C scatter plot, a BAC versus GS scatter plot, a BAC versus JPM scatter plot, and so on. So we have all of these tickers or banks on the x-axis, and then we have the same banks on the y-axis as well. So if you compare Wells Fargo return just to the Wells Fargo, it is a univariate data, and therefore we have a histogram. If you compare Wells Fargo to this other banks, we have a scatter plot to analyze the data. And it's very important to check the scales for this. Everything is in decimal on both x and y axis. Sometimes based on the data you can get different scale for one of the columns, and then that graph will look very different. Just check here, for example, this is going from minus 0.25 to 0.75. There is one outlier point here, and just this one point make it looks like this slope is much higher. But if you ignore this outlier, I think the slope will be much equal, as the distance from zero on both sides is almost equal for rest of the data points. Same with this Citibank return. On the negative side it's minus 0.25, on the positive side it's going up to 0.5 because of this one outlier point, but most of the points are within this range of minus 0.25 to 0.25. So if you analyze this for BAC returns compared to other banks, there's a very strong correlation between these banks or the returns of these banks, because as the x-axis goes up, the y-axis goes up as well, and that pattern is prevalent for all combinations of the for all pairs of the banks here. You have to be mindful of this outlier point, which makes it looks like the slope is higher on this map, but in reality it is not. If you want, we can quickly check the correlation between the returns as well. Just take our returns data and use correlation method. And here if you see, we have this correlation in a matrix format. We can use this later to create a heat map, but for now let's just see BAC versus BAC is obviously 1, but BAC versus Citibank is zero point 0.8 compared to Goldman Sachs is 0.68, JP Morgan is zero point 0.8, Morgan Stanley is 0.64, and WFC, which is Wells Fargo, is zero point 0.8 again. So it has very strong correlation with Citibank, with JP Morgan and Wells Fargo, and less stronger correlation with Goldman Sachs and Morgan Stanley. Similarly, you can check for other banks as well. Now let's move on to the next step. Using this returns data frame, figure out on what dates each bank stock had the best and worst single day returns. Did anything significant happen on those days? So let's check for our best single day return. So we have our returns data frame. Now if you just check for the max, it will return the max value of each column. If you check for ID X max, it will return you the index for each of the max value for each column. So because our index is the date, we can use this returns.idx max method, and it will return us the dates on which these banks had their best return. Let's check for the worst returns as well, and for this we can use idx. You guess it right, we can use idx min method. So we have our best performing days and worst performing days for each of these banks. Did anything significant happen on those days? Let's check the days first. If you look here closely, you will notice we have the same date for four of these banks: for Bank of America, for Goldman Sachs, for JP Morgan, and for Wells Fargo. All of these banks had their worst return on 1st January 2009. Was there anything significant? If you Google this date, you will find Barack Obama had his inauguration on that particular date. So, was it his inauguration which resulted in the widespread panic? No, not really. So, if you Google financial crisis 2008 on Google and go to the Wikipedia page, they have quite a lot of information regarding this financial crisis. If you drag down and check for these dates particularly, you will find that on this particular date, uh, the Iceland banks collapse. If you know any history of the banks in Iceland, during the boom of 2000 to 2007 years, those banks were privatized, and then they saw quite a bit of boom years, so much so that their entire economy, their entire GDP became dependent on the performance of these banks. And when the economy collapsed, their bank collapsed and their government collapsed as well. And so that created a widespread panic that would have caused big declines, especially for these bank stocks worldwide. For the Citibank, which has a different date, on this 27th February, US government increased its stakes in the Citibank. I think it was to 35%, and that raised concerns among the investors regarding the nationalization of the bank, and that's why it had its biggest decline on that particular day. If you notice this JP Morgan returns, its best performing day was just a day after the worst performing day, uh, on first on 20th January, and the reason for that was it received a $700 billion bailout from the Federal Reserve. So we have our best and worst performing days for these stocks. Now let's move on. We want to check how risky these stocks are, and the way to do that is to look at the standard deviation of the returns. So if you know anything about investing, you would know that there are two kinds of investors. One are those who look closely at the business behind the stocks, and if they like the business and they believe the business is going to grow tenfold in next 10 years, they know that their stock price is going to grow tenfold as well. These kind of investors are called value investors, the likes of Warren Buffett. For them the risk is not the movement in the stock price, that is just the volatility. There is a second kind of investors who actually make money just by the movement of the stock prices by trading frequently, and for them the movement on the stock price is a risk. So they calculate the standard deviation of these movements of these daily returns, and they consider this as the risk. So we have to find the risk of the stocks over this entire period and then for the year 2015. And we have to check which among these were the riskiest stock. The riskiest would be the one with highest standard deviation, but then that would be based on the return as well. So what we have to do here is take our data frame and check for the standard deviation for each column. And if you see closely here, there isn't much to differentiate between these stocks. Statistically, you can say Citibank is the most riskiest, but it's only by the barest of margin. It's in thousands of decimal places, so really insignificant. Practically, they all had similar risk. Now let's just check for the single year 2015. What we can do here is we have to restrict our data to this year 2015. We can index it starting from 2015. So here our data frame is restricted to just 252 rows, which would be trading days for this year 2015. Now check for standard deviation. And similarly, if you see this standard deviation, there is not much difference between the standard deviation for each of these columns. So they all had similar risk for 2015 as well. So there isn't much to read between these stocks. Now next, we have to create a histogram using Seabound for 2015 returns of Morgan Stanley. So we have to restrict our data frame first for 2015 data and then just for Morgan Stanley. This returns data. Again, we have to use this .loc method for row indexing. We can pass in this dates as string. Then we need it just for Morgan Stanley. And now we have to create a histogram using this series data. And we have our histogram here. Let's make some changes to this just for aesthetic purposes. We can change the color to, let's say, green, and we can increase the bins as well. Let's say we use 50 because we do have 250 rows. Let's put a KD graph on this as well. Now we will do one thing. It's hard to read the data here, so we will put a grid, go back up for Seabound. What we can do here is use sns.set style, and if you go down and check, there are 4 kinds of style given here, actually 5 kinds of style. Those are dark grid, white grid, dark, white, and text. By default it has white, which is giving white background in that visualization. We can select white grid here. Now if you go back down and run this again, so we have the grids here, and if you see the data, most of the data is between negative 0.02 to positive 0.02. If you imagine this in terms of percentage by multiplying each of these numbers by 100, so most of the daily return were within plus minus 2% of the previous day number. Now let's create another histogram for the 2008 return of Citigroup. This time we will do the same thing for returns. We have to restrict this row index to just 2008. then index C returns. Now pass this through a histogram plot. Now that style grid that we pass, that will be applicable globally, and all the visualizations we plot today would, would automatically have this white grid as their background. If you want to change that, you need to change that argument once again. Here, let's change some parameters for this. Let's use the red color this time. Rather than using the entire name red, we can just pass in this alphabet R. Then we will change the bins to have 50 bins, and we'll uh, get our KD graph as well. Here, if you check the KD graph, you will notice we have a long tail on the right side. That is because of some data here near 0.06. So basically it says that there were days where there were very high return, but there were only few days, maybe just one day. It could be 1 or 2 days. All right, moving on. So if you want to create this graph, you can use Seaborn, but you can also use Matplotlib, or you can make interactive graph using Plotly and cufflinks. We will do that in a while. We will plot some interactive graph as well, or you can just simply use Pandas built-in visualization tools. Next, create a line plot showing close price for each bank for the entire index of time. So we are back to our closing price. So we would have to see the cross section of the original bank stocks data frame, because if you check the head of this data frame, we have all of these additional columns. Here we want to plot just the closing price, so we will take a cross section. So this is our data frame which we need to plot. We can directly use the pandas built-in plotting method with kind is equal to line, because we are looking for line graph for this. Let's increase the figure size. So here if you see, these line graphs are plotting their closing price for each trading day. And if you see this orange one, this is for Citigroup, and looks like this had a sharp fall from the price was trading around 500 in early 2008, mid 2008, and then by the end of 2009 it had a very sharp fall and came around 50 rupees, and then it never really got back up. Now a better way of plotting this is using Plotly. Let's get our cross section of the data frame. You can actually use the same code. We will remove this figure size because that argument is not that parameter is not there in iplot, and just change the code by adding just this one character I in place of dot plot. Here with the data frame we will use dot iplot, pass in the kind, and tada, now you get a interactive graph. What we can do here is, if you want just to notice the behavior of the Citibank, you can turn off this other lines, and now if you see, the Citibank dropped from around 500 to 21. And see, this is something you don't have in your normal pandas or matplotlib graph. You don't see the exact price here. You just know it is somewhere between 0 and 100. But here if you hover over the graph, it will give you the data points as well. And then if you want, you can zoom in to study a particular area of the graph and then pan and go across other areas in that zoom view itself. And then if you want to come back, just reset scale or auto scale. If you want to study the other banks performance, you can individually select those. If you want to compare the performance across multiple banks, you can select it together. So this graph is a lot more helpful than compared to the normal pandas graph. Let's switch this back up. We can see the performance of the other graph, which looks like didn't move a lot. This is just based on the scale. If you remove the Citibank and the Goldman Sachs, and now you will see variation in the graph of these banks as well. But with Citibank, because of the scale it had, it dropped from 500 to 50. It looks like the other banks were just forming a straight line. So this is really helpful. Now let's move on. Now we will calculate some moving averages. So let's analyze the moving averages for these stocks in the year 2008. Plot the rolling 30-day average against the close price for Bank of America stocks for the year 2008. So we just need this for Bank of America. So we don't really need to take cross section here because we just need to analyze it for one ticker. What we could do here is just first index it for Bank of America. This will return a small data frame just for the Bank of America. And it's even easier. You don't need to do this. We have our original data frame for Bank of America. You can just call that. It's the same data frame. Now took the closed data. Before that, we need it for the year 2008. So use location index. So you can see the start date and end date here. Now we will index the close column. Now here it will return a series data. We have a rolling method. What is rolling 30-day average? That is, it will calculate an average for the first 30 days of data, first 30 rows here, and then it will move one up. So the period will be fixed 30 days. It will start for the first 30 day, and then it will move to 31st day. It will drop the first day, then it will drop the second day, and it will move from third to 32nd day. So it will always have 30 day, but it will keep moving one by one. Imagine it as a window of 30 days, but which will start right at the top, and then it will keep moving down one by one, and at the end it will give an average of the last 30 days of data. So to do that, we have to first create a rolling, and we will give our window of 30 days. You could also calculate it for 15 days, for 60 days, whatever you want. And then for this we will create an average in place of mean. If you want sum of the 30 days for some other data set, you could do that, or you could use any arithmetic. If you want to calculate the standard deviation for 30 days data, you could do that. So what this gives here is it produces a series. If you look at the first 5 columns here, it's all not applicable because there wasn't 30 days of data here. If you check the head with 32 days, now you see for the first 29 rows we will have just the nan, that is null value, and then we will have rolling averages, and you can see this average is changing based on each day data. So we can do one thing, we can start plotting this. and then we will plot a graph. So what we have to do here is plot the rolling 30-day average. So we have done this. This is the graph of the rolling 30-day average. This is against the closing price of Bank of America stock. So I can just copy paste this. This is restricting this Bank of America data frame to just the year 2008 and then to this column close and plot here. And the Jupyter notebook will automatically uh, plot those on the same graph. If you want legend to show here as well, we can pass in labels. Label, this is 30-day average. This is just closing data, close, and then plt dot legends. And here if you see the difference between this rolling average and the actual stock prices, the stock prices can have sharp declines and inclines. What this 30-day average does is it ignores those sharp edges and smoothens the data based on average of the last 30 days at each point. And it's this is basically used to analyze the stock data, and so that sudden falls can be ignored, and it's not part of your stock analysis unless it is sustained over a longer period of time. So here if you can see, the stock started falling but the average price was still high, and because it sustained over a period of time, slowly this average came down as well. It has much more roundish edge, and this is a sharp edge here. The same thing happens on the upside as well. We have to create a heat map of the correlation between the stock's close price. So what we have to do is we have our original data frame which has the stock price for all of the tickers. We will take a cross section just for this close column. So this is the data frame with just the closing price. We'll take a correlation of this data frame. Now we have to plot a heat map, so we can do that just around this data frame. We can change the color for this. Let's use magma color combination. You can check for this CMap or different color palettes for Matplotlib and Seaborn on Google. You will go to their official website for Matplotlib and Seaborn, and you can check all of the available options there. And what I'm going to do here, the darker colors are on the lower value and lighter colors are on the higher value, which is not very intuitive. So I'm going to reverse this using underscore R at the end of the color combination. And now the darker ones are in black, the lighter ones are in yellow, and for higher values it keeps on going darker and darker. This is easier to understand. I will also use a knot to get the value for each of these square boxes. So if you see, obviously the Bank of America to Bank of America correlation is 1. But if you see the Bank of America correlation basically says if the stock price for Bank of America increases, what is the movement of the stock price for the other banks. So it's basically denoting a linear relationship between those. Positive relationship will mean if the price of one bank increases, the price of other banks increase as well. A negative relation will show a movement on the negative direction, other direction compared to that stock. A higher value This correlation always varies between -1 to 1. A 1 would mean perfect correlation. That means both of those goes up at the same time and goes down in the same time. A negative correlation, -1, will mean every time one stock goes up, the other stock goes down. And correlation of 0 would mean they don't have a correlation among themselves. So the movement of one stock has no relation with the movement of the other stock. These are used by the hedge funds and other guys who take a lot of risk to hedge their risk based on the movement of the stock prices. So if they are betting on Bank of America to go up and it has a negative correlation with some other stock, they can buy some position, they can make some position in that other stock as well. uh, so just in case if Bank of America goes down, the other stock will go up, thereby they will not be losing as much money. So here you can clearly see this Bank of America has strong correlations with the Citibank and this Morgan Stanley, and weak correlation with Wells Fargo. That is very weak, it's 0.0085. Even with JP Morgan it's just zero point 0.1. That is very weak correlation, it's very close to zero, and that basically means they have no correlation. With Goldman Sachs it's midway, and you can check that for other stocks as well. Now next we will create a cluster map for this. We will use sns.clustermap once again for our bank stock. We can just copy paste this part of the code, and here if you check the signature, the size is by default given 10 by 10. So we'll decrease the size so that we can see the entire figure on our screen. We will make it 6 by 6. Once again the darker portion is on the lower value, lighter portion is on the higher value. We will change this using the CMap parameter. Now what does cluster map does is it creates a cluster based on the close data. So here both on the x and y axis you see it has put Bank of America together with Citibank and Morgan Stanley, and we saw above in the heat map that it's had very strong correlation with Citibank and with Morgan Stanley, and Wells Fargo and JP Morgan were close together to each other. So in the cluster map those Wells Fargo and JP Morgan has been put together as well, and this Goldman Sachs is somewhere in between for both rows and column. So it has essentially created a cluster for these banks. One cluster is for Citibank, Bank of America, and Morgan Stanley. The other cluster is Wells Fargo and JP Morgan. And then Goldman Sachs is in between somewhere from both of these clusters. In the second part of the project, we will rely on the cufflinks library to create some technical analysis plot. So as you know, cufflinks connect the pandas data frame to Plotly, and we can directly plot those interactive graphs from the pandas data frame. So what we have to do first is to use iplot candle kind to create a candle plot of Bank of America stock from 1st Jan 2015 to 1st Jan 2016. So we have our Bank of America data frame. We have to restrict this to Jan 1st 2015 to Jan 1st, 2016. Remember, the 1st Jan would be a holiday, so last trading day was 31st December 2015. And for the candle plot, we need 4 columns: open, high, low, and close. This Plotly would be automatically able to take data from these columns and ignore the adjust close and volume column. So what we will do here is just use iplot kind is equal to candle. Plot this, and here we have got our candle plots. If you look closely, you can use the zoom, go to any point. If you go to any data point or any candles, you will get the date of that and the data for open, high, low, and close. This is used for technical analysis for the stock data. We won't go too deep into this, but this is available if you want to use it. Reset this. We'll go to the next plot, which is SMA, simple moving average. So what we have to do here is, this is for Morgan Stanley for the year 2015. And what we have to do here is create simple moving average. We will take just one column here for close data, which is the price of the stock at the close of the day, and we will plot. So actually for this one, unlike the last one, we have a method available which is for technical analysis, which is ta underscore plot. This is coming from cufflinks, and here you can pass in the steady SMA. There are two options here. One is SMA simple moving average, the other one is RSI. If you want to check the resistance and strength of the stocks, I will show you the other one as well, but before that, let's run this one. So this is basically plotting a simple moving average over the actual closing stock price. As we talked earlier, this simple moving average smoothens the edges of the stock. Now what we could do here is, this is showing a simple moving average by default for 14 days, 14 trading days. What you could do here is, you can pass in another parameter called period and pass in a list of different days you would like to analyze. I'm going to pass 14 days, 21 days, and 55 days, and this will create a moving average line for each of these days. Now if you want to study this individually, you can switch off the days you don't want. You can check for the 55 days, and if you want to compare that against 14-day moving average or 21-day, you can plot that as well and study it separately. Now let's do the same thing for the RSI. RSI is very famous for technical analysis, and here we have our RSI given separately here for 14 days data, and it is showing the strength line. This is the resistance line on top and the strength line on the bottom. Now for the last one, we will use Bank of America stock for 2015 data. Now we can use this. We will again sort it just to index it just for the close column, and then use this TA underscore plot with steady as Bollinger band. Boll is short for Bollinger band. And what this Bollinger does is it creates three lines. One is simple moving average, then it has an upper line and it has a lower line as well. You can once again switch on, switch off these lines to study it. So now we will just update the start and end dates and rerun the code to analyze the last 10 years performance. So here we will go to our start and end object. We will just update these dates. We will start at 2014 and then we will go up until 2024. We'll go to 9 month, that is September, and we will select 15th date. Run this, and now if you check our start and end object, it is last 10 years date. Run this codes once again. Remember the last time this codes downloaded the data from 2006 to 2016. Now it will download from 2014 till date. Here you can rerun this data frame and see. Now it is showing data from 2014 till 2024. You can check for other data frames as well. Here run this again. Now it has updated date. Now here, rather than rerunning the code, we will copy paste this and run again, and this will give us the updated return for the last 10 years. So what we have here is max close price, and you can see the difference between the max close price for this 10-year period and the last 10-year period. So you can see here for the Citibank, the max closing price for the original 10-year data was $564. Now it is down to $81. Goldman Sachs on the other end has gone up to $510 from 247. You can see the difference for other stocks as well. Now we will rerun this codes. And here you can see the difference this is for the original data frame and this one is for our new data frame for last 10 years data. Now let's run the pair plot. It can take a while. And we have pretty similar data, but you'd remember for Morgan Stanley there was an outlier, and that was showing a much steeper curve for the scatter plot. That is not there anymore, and all of these data looks to have much more closer correlation now than compared to earlier plot. We'll check this. Yeah, see now for the new data everything is 0.8 upwards, so all of these stocks has had much closer correlation in last 10 years. Earlier Bank of America, Citibank and JP Morgan had one clustering. Now let's check for the best and worst return days. Those would be returns with IDX max. and best return days are in 2020. We'll check the IDX min as well. And remember what happened in March 2020? It was COVID period. So it's so weird. All of these stocks had their best return on 13th March and then the worst return is on 16th March. I think 16th March was around the time when everything started closing down. But why did they have such high return on 13th March? If you want, you can Google it. But one thing is for certain, there was a lot of volatility in that month. We'll check the standard deviation as well. We'll just check for the overall 10-year period, and for the first 10-year period you can see the data. The standard deviation was around 0.03 for each of these. Now it's around 0.02, 0.017, 0.016, closer to 0.02. So much less standard deviation. That means the returns haven't deviated that much in last 10 years, which kind of makes sense. We have been in a long bull run now. So I'm going to leave it right there. If you want, you can go ahead and visualize the data with the new dates. For now, this has been a long video, so I'm not going to redo all of those again, but you can obviously do and check it. I will run it for this one, for the heat map, and you can see the clustering is a lot more closer now compared to earlier. The colors are a lot more darker. So that's all for this video. Thanks for watching.